It's been forever. It's been forever, but I'm back. I am back. I'm Gabe, the O-Scope Wizard. Thanks for joining me. We're in the middle. We are in the middle of building a wireless subwoofer in a bucket. I have a 5-gallon bucket. Let's see if I can grab it. It's over here. You probably haven't seen this guy in a while. I haven't seen it in a while. But I have a subwoofer in this bucket, and we're trying to make sound come out of it wirelessly. Now, the key is I want the sound synchronized between the speakers in my driveway and this subwoofer that I'm one day going to bury into a hole in the side of the driveway to just push noise pollution deep into my neighbor's yards. Also, subwoofers really just fill out the bottom end of sound, and I miss it out there in the driveway when I have the little speakers running on the side of the house. No bottom end. Where are my 808s? Give me the 808s. In the last couple of episodes, we've been working on getting sound to the subwoofer. We've been working on filtering the sound going into the subwoofer to see into the subwoofer to see what our filter network might ultimately look like. And today I have, as luck would have it, I have a whole bunch of stuff to actually build up a signal chain. So from our device that's actually going to handle the signal processing out to the subwoofer. I might even turn my camera just a little bit to point over here as I turn. Oh, can I do that? I think I can. Here we go. We're doing it. Making it happen. Signal chain starts with our trusty Raspberry Pi Zero. Why the Raspberry Pi? Well, one of the big reasons is because I understand them and I can put images on them, so try a bunch of different things really quickly. And they have these really handy GPIOs, so I can get signals in and out of the Raspberry Pi easily. So we're going to go with the Raspberry Pi. I already have an image that I'm using. I have converted my amplifier box that we built before, DIY Sonos style amplifier. I've converted it to Pi Core Player, which is a Linux image for the Raspberry Pi based on Tiny Core Linux. So it's a very small image. The benefit of using that small image is that it boots up pretty quickly on the Raspberry Pi Zero, which was a big thing for me. I don't want to wait for 30 seconds every time the power flashes and I'm waiting on my subwoofer to turn on. It's just the expectation with a wireless speaker is that it's almost instantaneously on. If you think about your Bluetooth speakers you want those things to turn on quickly. So I have the Raspberry Pi. We need to get power to it. So I have my DC to DC adapter right here, a DC to DC converter. Right now I'm using a 12-volt supply to actually get some glare. Let's see if I can get the glare off. There we go. Less glare. I'm using a 12-volt supply to get power to all of my components. So from that 12-volt supply, I need to create a 5-volt supply for the Raspberry Pi. Next, I need to put a DAC in the signal path. So this is my digital to analog converter. This guy is going to take I2S signals from the Raspberry Pi and convert it out to audio signals, which we've done in the past. It's pretty simple to wire up. Hopefully I can get this all wired on the show today. It's always exciting to wire on camera because you never know if you're going to lit the smoke out of something. And I've lit the smoke out of something. And then the next piece in the puzzle is power for this DAC. So I know that if I use the Raspberry Pi to power the other components in my system, because the Raspberry Pi does have a 3.3 volt supply, and this DAC needs 3.3 volts for power. I think, can we focus on there? Does it show it? There we go. You can see 3.3 volts. That's what it wants. If I use the 3.3 volt lines from the Raspberry Pi, our past experience tells us that is going to add some serious noise to the audio signal. So I'm going to use this linear regulator to go from 12 volts out to 3.3 volts, because this Regulator makes a super clean and stable power supply, which is key to keeping your audio channel sounding good. You don't want extra hiss. The next piece in the puzzle is my amplifier. So this little guy is a, well, let's see what it is. It's a TPA3118. Allegedly, it's a 50-watt amplifier. I think it might actually be a 50-watt amplifier if I, let's see, TPA3118. Let's find a data sheet. And let's check it out. We love a good data sheet. Boom. TPA311. Oh, 30-watt stereo, 30-watt stereo, 60-watt mono. So this is a 60-watt amplifier, which I think is going to be plenty for our subwoofer outside. The other amplifier that I'm using for the speakers, I think that was a 50-watt amplifier, 50-watt stereo, so 50 watt on each channel. And this is 60 watts on one channel. And the subwoofer is bigger, so uses more power because I got a bigger voice coil to move around. And I think this will be plenty, but look how little this guy is. This is a little tiny little Class D amplifier, and it's going to run on 12 volts. I think that actually is, let's check the data sheet to make sure. What we found before is if we did not supply the right voltage to the power input of these amplifiers, it would not always give us the full output. Okay, this once again looks like to get my full 60 watts, I probably want to operate it at 24 volts. You know, that's a bridge we'll cross in the future. Right now, I have a 12-volt supply, so let's use that and see if we can get our signal path at least flowing well and sound coming out of the speakers before we start worrying about, you know, optimizing the design. I don't want to get stuck optimizing the design before we even have a design to optimize. So maybe I start with wiring this thing up. So on my breadboard over here, I have some connections. I have a red and black connection right here. That is from my power supply, which is way over in the corner. And then right here, this blue and black connection, this is just my multimeter. I have it set up there so that I can make kind of quick on-the-fly measurements to make sure everything is plugged in right, so I don't let too much smoke out during the plugging in of things. I always get a little nervous when we first start. Let's start with getting power to this Raspberry Pi. So I have this little DC to DC converter to supply power to it. This little DC to DC converter is, oh my goodness, guys, I'm gonna have to really, I think it's the MP1584. It's the MP1584EN. I like it because it's so tiny. I mean, it is just teeny tiny. So let's make sure I get my ins and outs wired up properly. So ins and outs. Get a couple of cables over here. Go from my breadboard, so I have power on one bus and ground on the other bus. Ground to input negative, and power to input positive. And I'm going to use this as my, that cable is really loose. I hate it when the cables get a little loose here. See if I can get another cable that may be less loose. I don't want it to slip off. That could be disastrous. Input. There we go. Not loose. That cable is worn out. Now, a true engineer would just put that back in the stack, but I think I'm gonna make a bold move. I'm gonna make a bold move, and I'm gonna throw this cable away. Nobody does that. No lab throws away cables. Everybody knows you just put them back in the stack and keep going. That's a joke. You should throw away bad cables. Throw away bad cables when you find them. You don't want to be that guy. That guy there with the bad cables. Now I want to measure the output of this DC to DC regulator and make sure that I'm getting 5 volts. So I have 12 volt rail that I want to convert down to 5 volts so that I don't kill my Raspberry Pi. Raspberry Pi is pretty ticky about voltage. It wants to be right on around 5 volts. If you get a little bit lower, it starts rebooting. If you get a lot higher, it starts dying. And we don't want either one of those things to happen. Also, while I'm at it, since I'm just wiring up some power regulators, let's get my linear regulator going here so that I can also measure this. And I want this to be 3.3 volts or thereabouts. That is the dream. Another experiment that I'm going to do down the line, and I have them on the way, is a isolated voltage regulator. Benefit of that is any noise that happens on my big rail would not be sent out to my 3.3 volt rail. And since this is what is powering the audio DAC, any noise on my 12 volt rail would get out to the audio. And what you'll hear is like a little bit of a hiss. And it's just unpleasant, not great. Okay, so now I have two voltage regulators plugged in. Let's turn them on by plugging in my power supply. Ooh. Okay, 5 volts, 5.2 volts. Can you see it? 5.2 volts. So this power regulator, this voltage regulator is doing good work, doing exactly what we want it to do. Now let's plug my cables into my other voltage regulator. So ground this one, and V out is this one, and 3.3 volts. 3.3 volts, 3.3 is perfect. So both of my voltage regulators are set up to power their respective chips. So let's unplug it. Another thing a real pro would probably do is add a switch to that power supply, so he doesn't have to continue plugging and unplugging the cable. But I'm the O-scope wizard, not the power supply wizard, not the plugging it in right wizard. Also, we're just kind of prototyping here, so we're going for a proof of concept. So this is my output positive voltage for my Raspberry Pi. So this is my 5 volt rail. Let's plug that in. So we got 5 volts going into the Raspberry Pi and ground going into the Raspberry Pi. It's funny how some engineers get real weird about calling a rail ground. Maybe we'll call that the return path, because it's going to be different as the circuit moves around as we try to keep these different systems on separate return paths. Okay, so I have ground right there. Ooh. Now you'll notice I have a lot of little wire wrapped onto the edge of this, and that is because some of these control lines need to be held high or low depending on their functionality for this chip. Now this is a 5102 PCM5102 DAC, which is the same chip that we used before in our DIY Sonos style amplifier. I liked the sound of it. I understood it. I had wired it up correctly before, so I thought I would stick with what worked. That's not great. One of the things I could do really quickly is add a little wire wrap to that. Could also just press this on extra good. See if I can just press it on there so it kind of grab. Let's see. Okay, I think we got it. I think we have. Well, you know what? It'll very quickly tell us whether we have it or not because there is a small LED on this little DAC board that illuminates if it gets power. Now I have VCC and ground onto this guy. The next step in the plugging in is to get my I2S lines from over here to over here. So from my Raspberry Pi to my DAC. If I go to one of my favorite little Raspberry Pi websites, pinamp.xyz, and I select PCM because this is audio. The Raspberry Pi is a form of digital audio output that's understood by a DAC. That's what I want. And I want to go from GPIO 18, GPIO 19, and GPIO 21 for data out. So let's wire that up. So where's my webcam? There we go. 18 right here was clock, I believe. So on my DAC, that is B clock, bit clock. The next one was frame select, or often called left-right clock. That is GPIO 19. So I have this little shield on my Raspberry Pi. Focus. This little shield goes over the GPIO pins and it labels them for me so that I know what I'm plugging it in, what I'm plugging into. You can also get breadboards that have that. And I have one of those, but it's already plugged in and in use on a different experiment that I was doing, and I didn't want to tear it all apart. So there we go. GPIO 19. That is L clock. In this case, L clock, which is left-right clock, is what we plug it into. And then finally, my data. So GPIO 21 down here in the bottom. Data input to my DAC. Come on, guys. There we go. That ground there is probably going to be real trouble. Feel like it's going to give me a headache. Now I could have gotten my soldering out. I could have gotten my soldering iron out, but I just got my wire wrap tool out. I'm going to plug it in. If it doesn't have a super steady connection, or if it tends to get loose, then I'll wire wrap it. That's not a big deal. That's what I love about wire wrap. It's not a big deal. So I'm going to use some of this little putty to hold everything down. Da 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 da. That settle down. Perfect. This will be a little steady. Next, I need to get power to my amplifier. So on the back, I have my input and my output, and then my power rail. So let's just get power, and we're going to go right off the 12-volt rail here. I have a couple little extra connections. Actually, let's do it right. Let's do it right. Ground. It's on this side. And power is on this side. Now I have power. Now, input. This DAC is it's many things, but one of the things it is a stereo output. And this amplifier board is a mono amplifier board, so it is one channel input versus a two channel output. So I actually have a solution for that, and that is this little pre-amplifier board that I bought. And it does a few things. So this is a subwoofer pre-amplifier. It has a volume knob right here. It also has a filter cutoff, so it has an adjustable filter, low-pass filter. And it takes in a stereo input and spits out a mono output. So it does a bunch of things for me. And I tested it yesterday on the bench. And the thing that I like the best about it is that it sounds really good. It just sounds good. And sound is such a subjective quality. How much do you like something? That means that's totally subjective, right? It's based on your preferences. But I'm going to start with just taking one side of my stereo output and running it right into the input, since we are just simply doing a kind of a prototype here. So the input should have swooped this over a little bit. Output to input. I'm a little nervous I'm going to blow all this up. Every time I plug it in and unplug it, nervous I'm going to blow it up. Nervous I'm going to blow it. Also nervous that that ground is going to come flying. It's going to be great. Great at all. Yeah, let's just wire wrap. Just wire wrap. Ground and power. One signal. Have some wire wrap. I have the technology. I have some wire wrap right here. I have the wire wrap tool right here. So we'll wire wrap it. Wire wrapping. Such a cool, quick way of prototyping. And it gives you a nice solid connection. And I've never done it in front of anybody. This will probably be the source of much ridicule. No doubt. I'm sure I'm doing it wrong. One of my friends, a fellow electrical engineer, much better embedded engineer than I am, actually has a wire wrap gun. So he has taken it to an extreme. Anytime you get a gun, you go extreme. Heat gun, glue gun. You could have just regular glued, my man, but I got a gun. Wire wrap gun? Sure. Ground to ground. I mean, getting so much wire on there, I'm going to run out of... Is it actually going to make a connection? That's the question. It made a connection! It's like the... That post is full. This post here is full. So the ground is full. No more grounds allowed. Let's get the power. I think I'm actually just going to use a regular cable for the power. Don't tell anybody. One wire wrap is enough to do live on camera. Made me so nervous. I'm going to end up with sweat stains everywhere. Okay, let me get my putty out so it can stick down a little bit more. Ooh, ooh, ooh. My signal path, power going into the Raspberry Pi, power going into my DAC with one wire wrapped wire. Signal, the digital audio signal going from my Raspberry Pi to my PCM5102 DAC, and then the audio signal going from my DAC out to my amplifier board. And then finally, yeah, my amplifier board, here it has some leads going to my subwoofer. So these are my, let's see if we can show, subwoofer right down there on the floor, leads going to it. Let's plug those in. Negative, it doesn't really matter, it'll just be in phase or out of phase to nothing really. Should we plug it in? Let's plug it in and see if anything dies. Okay, it did pop. It's another little bit of power. LED on my DAC is up. LED on my amp is up. The LED on my Pi is flashing. So now that I have a signal path there, I think we're to the point that we can actually go and find this thing. Oh, my multimeter is saying, take a break, dude. Take a break. But I kind of want to come over here and see if we can find it. So here is my garage amp tiny core Linux page that allows me to control it. You can set up the speaker. And so this is the setup for my main amplifier, the Sonos style amplifier. We should also have a page for, I think it's the driveway. Let's see if we can find it. Driveway subwoofer.local. Does that come up? Should have. Come on, man. Come on, man. Local. There we go. It came up. Okay, driveway subwoofer.local. That means the Raspberry Pi is up on this little itty bitty Raspberry Pi Zero. Where are we at? Where are we at? Right here. This little guy is up and running Tiny Core Linux. The Pi Core player image. So I need to make sure that its settings, audio output device is a TI-5102 DAC. Thumbs up. Driveway subwoofer. That's the name of my Tiny Core player. And I'm running Squeeze Lite. So we talked about this a little bit before. Squeeze Lite is the name of an audio device in the Logitech media server ecosystem. So this is a way to send audio via Wi-Fi synchronized to a bunch of different devices. Before, I was trying to run this media server on a Raspberry Pi, so the LMS media server on the Raspberry Pi. But what happened if I did this is it was slow. It had a lot of trouble with connectivity. So I kind of I zigged and zagged. So one of the things we have here at the Techno Lair for the Oscope Wizard is a proper server, an Unraid server. If you haven't checked out Unraid servers, check it out. You can do all sorts of things on a server. You can store files, you can have a web page, you can also have a Logitech media server running on your server computer. So I have a server computer running Logitech media server. Now we're getting a little bit meta. That's fine. What I can do with this Logitech media server, though, is I can configure it to play audio to two or more things all at the same time using some different plugins. So one of the plugins is Group Players. So after you get your Logitech media server installed, and maybe I'll even show a video of how to do that really quickly, although I'm not very good at that style of video. Google it. Logitech media server, install it, super simple. Then choose a plugin, and the plugin that I am going to recommend is Group Players. And what that plugin allows me to do is create a group of in this case, 2 speakers. So I have my driveway subwoofer speaker, and I have my garage amp speaker. And that was configured out here. So in my squeeze light, I have garage amp for one of my speakers. And then for my other speaker, I go to squeeze light. And, that configures the speaker for me. It says driveway subwoofer. So now I have 2 speakers that I can send audio to. And I'm going to attempt to do that now. We'll see if this works. This will be where it totally failed. So if I just go over here, choose my player will be driveway, which is a combination of garage amp and driveway subwoofer. And I just hit play.
You say 1 for the trouble, 2 for the time.
Probably got all kinds of copyright hits for that, but it does play, and you can hear that the sound is synchronized between both speakers. It is amazing. It's awesome. I clearly need to do a little work to figure out why it doesn't always pop up into my Spotify app. That can be a little squirrely, but it's working. I have synchronized sound between my subwoofer and my garage amp. So I think, we're getting close. We're getting close to making a wireless subwoofer and a 5-gallon bucket all work. I am excited. Next episode, let's figure out maybe how to package this subwoofer all together so we can attempt to bury it. That might be a good next step. Figure out how to put it in a box so that we can bury it. Anyway, I don't know all the nerds out there, and I would love to meet them. So please share this with the nerd in your life, and I'll see you guys later. Bye.